Well, again, this is Dan Hobson with Photons from Space, and going to continue on with processing the images that I took on October 12th. We'll switch over to the desktop. Okay, here we go. Go to the first object, C20. Post-processing, pre-processing. Lights and masters. We have our masters in here, which we took the other day. And we have our lights in this directory. And so what we're going to do is use those masters and calibrate the lights. Basically, account for the dark current, and also the flat field, and which is the optics. We're going to count. Okay, we're going to count for the noise in the camera itself and the distortion in the optics. That's the two things we're going to account for in this. And we're going to take 100 frames or close to it. Depending if there was some drop, we'll get less than that, but it'll be more than 95 frames and maximum of 100 frames. We're going to taking that, we're going to correct all of them. We're going to calibrate all of them, and then we're going to stack those, which will give us an average. And so we should get some really good images here. And so hang on, here we go. Open that. If you run the script, we made the calibration masters with this command. We're going to come down and process from master dark and flat. Click that, and now we're going to go in. So now we're pre-processing with current memory. 12 threads. And now we're taking light images. Now we're calibrating the lights. That's what this is the process of doing here. And the bar here, the progress bar, we'll make it over here eventually. I don't think it'll take too long. It's a little longer than making the flats, but not too much longer. While it's doing that, I'll show the script that I wrote. Basically took this is a script. See, it's going to be, the script here is what this comes with the Siril Software. So I took that script and broke it out into making masters, and then rewrote this one to take those masters and process the light frames. So it's converted the light into a series, convert light frames to fit files, and it makes a sequence of those files, calibrates them, which is what it's doing now. After they're calibrated, they'll be aligned. It will look at the stars in each one of those images and line those up one on top of the other, and then it will stack them, which basically does an average. And it also there's some sub commands in here. It equalizes the red, blue, green channel. Basically equalize the color, and it puts the output into a result. And the last thing it does, the result is for something in the process flips it upside down, so this flips it back, loads it back in, converts it back up, and saves it back out. Adds the timestamp in the file name, and closes. So that's what this script is doing. This is the console output here. that's going through. So it's still doing the calibrations. It hasn't got to where it registers it, which is where it lines things up yet. It's still calibrating it. And this is also what's called, there's a process called debayer. It takes when the raw image is a black and white, and then it has a pattern information that tells you that tells the software when the camera captures an image, it captures uh, the basic pixels. Some pixels have a blue filter, some a green filter, and some a red filter, and they're in a pattern of four. There's two greens and a blue and a red, and so this RGGB, that's that pixel pattern, and so that gets converted into a single color pixel on the computer. So we're getting close. Looking at the bar here, we've made a lot of progress. We were over here, now we're off to the right, about 3/4 of the way through. So we should be finished with the calibration soon. The file names are PP Lite, which is the calibrated. That will change to RPP when it gets to the alignment procedure. Getting close. Given the progress bar, I would say that the registration will go very quickly. So it's processing line 27. That line 27 corresponds to this line 27 right here, where it does the calibrate command. Here we go. Now we're lined up. So yeah, it's saving us R-_PP. So this is doing the alignment process, and the bar is back to the left. So I guess this isn't going to be very quick, but it will. It's looking at these parameters here. It's killing this image in layers. Not sure what the inliers is. The scale X, scale Y. That's the magnification of the X and Y direction. And it has a rotation scale. Rotation, then it moves X and Y direction, so it shows this dx dy. That's how much it has to move to get lined up with the reference frame. It goes through all of the 100 frames in the images and picks what it thinks is the best one for a reference, and everything else is referenced off of that. So let's see, we got image 50. It also doesn't have these in order. It reorders them probably the best to the worst. So it's image 57, 69. 4172. One 75 70 matching stars and image. It even tells how many stars it found in the image. 655 in this image, 651. So it's using those to line up. Like it's halfway through now. So it says we're running line 30. But line 30 is this register PP light. And it's saving it into this RPP light. This next command will actually stack those. We'll take a normal add scale. Right now it's the calibrated, did the debayer. When it adds all the, takes the average of all the images, it will equalize the color after it's done. It also indicates down here which image is being processed. Image 23, 84. Still on image 85. Reading 100. Looks like it's saving all the results. So that's 33, so now it's actually stacking. So this is a quick process here. This process, maybe we'll flip it and we'll be done. And the PC fan came on real heavy, so it's working hard to get that done. Okay, we finished stacking, and there's our result. And then this end, it looks kind of boring. It's a dark image with a few stars. These are the bright stars that are in the image, and we're going to stretch that. The stretching that I'm doing is actually a histogram to kind of give you an idea of what a histogram looks like. So I'll take a logarithm. This is a linear, so from here on up, there's very few pixels in this that are at this brightness. Most pixels are almost here at 0, and we can expand that. Expanding out the horizontal width. And so from, say, 0 to out here to probably 300 or even 1,000. I think 1,000 is probably up here. You're seeing, 1,000 might be here. I'm exaggerating 2,000, but it's this is where all the information is. It's in that image, and we have to stretch that out. Taking the logarithm, which means that the few that are down here get bumped up. Go back to the full screen. And so we're going to stretch these, the input pixel values down here, the outputs over here. This line is the transfer function. This basically a one-to-one. And so what we're going to do is amplify that. Take these down here and put them, instead of having them show up down here, they're going to show up further up here. These in here would show up here. And so we're actually amplifying this signal. We're going to get a good look at it. I suspect it's going to be the North American Nebula, if I remember right. So let's just do an auto stretch that automatically sets it up. And so this is the North American Nebula. You can see this kind of resembles the United States, where you have California over here, you got Florida here, Mexico down into here, Texas is right here, and we have the Lone Star State right there, the little Lone Star there. Maine would be up here, Canada. It's kind of, that's where it got its name. But in future videos, I'll be processing that. For now, I'm going to go see if there should be a comet outside, and I want to go take a picture of that with a cell phone if possible. So until then, so back to the camera. Let's see, tilts are up there. There we go. Gotta get this smart camera going. It doesn't seem to know. It's one of these Insta things. It's supposed to be smart, but there we go. Now it's got its intelligence going. Okay, so until next time, I'll see you guys later from Photons from Space. Click and subscribe. Bye.